Hey everyone, so welcome to the sixth video of this math library programming series. So as I promised, this time we are going to be writing a matrix multiplication function. So before we move on to the actual algorithm, there is an exception, as with most of our functions have, and that is if the columns in on the left matrix is different from the rows in the right matrix, then we have a problem. So they have to be the same for this to work. So we're going to write that. So this is what we wanted to say, and just to make it more readable, I'm just going to bring this down. So so once I put this, so if I make this public on GitHub, you're going to see this all on one line. Actually, no, it would just be two lines. Never mind, I said that. So yeah, so once we get past this exception, we can create a new resulting product matrix. So the size of that is going to be the rows of the left matrix by the columns of the right matrix. Okay, so I did some matrix multiplication problems to generalize an algorithm. So essentially, here's what we're doing. So I'm going to write a double for loop just for illustration. Okay, so essentially what we want to do, so the entry, so the product at the row at index RC is going to be quote unquote a dot product of this current matrix. Let's call it the matrix A. So we want to do matrix A times matrix B. Then the entry R and C is going to be the dot product of the 0th row of A and the 0th column. All right. So we need to iterate through each part of. So we need to go through each row and column of A and B, and then we need to find their dot product. So the way you will learn this is you multiply row by column. So let's do that. So let's do. So we need like a temporary variable. And then in the end, we will, so once we update this value, I'm going to say product at R and C is equal to sum. I'm gonna go through each element, so I'm picturing this. So A at the 0th rows on the okay. Such a number of columns then. So in fact, yeah, let's just give this a more generic name. So call it I, since I haven't used I in this scope. And some, so we're going to add matrix at RI times m dot matrix at so on row I, column, I think here, so on column 0. This looks right. I don't want to quite confirm that. So then we're going to, then afterwards, we're going to set the value. Oof. 2. Matrix is now equal to product. And then let's test it out. I am very unsure about line 72. I'm very unsure about this. I did spend a lot of time thinking about this, so I hope this works. We don't need this. This will automatically figure out what to import for us. Let's go to new. Let's go 2 rows and 3 columns. So I want to send these guys values off camera, and I'll be right back. All right, so time to find out if our algorithm works. We do wait. So I'm just gonna walk you through what happened. So this is matrix A. This is matrix B. Right here. What's going on? Oh, somebody went out of bounds. See where it happened. 28. Okay. Let's have a look. Okay, so is that this main function? Yeah, so when I told you that I'm nervous about 72, this is why. Give me a minute. All right, so I may have fixed it. I believe the error was over here because I'm used to having just this rows but now I have a new matrix coming in, so I have to use its rows instead. So I hope that's a fix, and we're about to find out if these two multiply. Okay, that's not hard to fix. We just need to update that information. Okay, so this is 68 and 62. It's correct. So we have, okay, so first rate is 20 plus 30, 20, 30, that's 50, 50 plus 18, that is 68. And second entry, that is 3 times that's 30, plus 20, 50, plus 12, that's 62. Yep, so it looks like it works. So this is your matrix multiplication algorithm, and and next time we'll move on to one of two things. Either we'll take a break from this and do some more discrete math, or we'll start jumping into making transformation matrices. And, oh yeah, and also in between recordings, um, I'll make some other like miscellaneous functions that can potentially help us, but I'm not going to do them on camp because those are boring. So yeah, I'll see you next time.